So we had a rod, and we had the dimensions of the rod were given: mass m, length L. At a point P, from r distance from one of the ends of the rod, we had to find what is the net gravitational field. Total is equal to what? Now, the approach is that you consider a small mass at some distance x from the point of interest, which is point P, let's say. Now, this small element is of length dx. So find what is the mass of that, okay? Find dm first. It's a small field. So this would be given by the formula G small mass by the distance square. So will it be r square, x square, L square? What should I write in the denominator?
X square.
Yes, it's going to be x square. Now, I have to cover the entire rod, right? So either you go from left to right or right to left, up to you, okay? Whatever you do, make sure that the direction of this field is always towards the rod, because the force is attractive in nature. Gravitational force is attractive in nature, right? So you can account for that later or at the start, depends on you. Now let's start with the extreme end, this end, and then we'll move from left towards right like that. So then the net field will be the integral of this, and this will also be the integral on both the sides. What would be the limits? If I'm starting from this, the extreme left, and moving towards right slowly. So it depends on how you are traversing the rod, okay? It's going to give you the same result because we are anyway considering the direction of field at the end. So it has to be negative, I mean towards the left side. So we can do r plus L to r. You do this, please. It's not difficult. You get this result, and that would be the answer, okay? You check this out. You are going to get Gm, I'm talking about the magnitude, upon, so Gm by L, and 1 by r minus 1 by, so the upper limit is r and the lower limit is L plus r. This is what you are going to get, okay? You simplify this further, you'll get Gm r plus L here minus r, so L will get cancelled, and you'll get r plus L. So this would be the value of gravitational field. Okay. Now we discussed about the principle of superposition also, right? That how forces add up like vectors, and how fields add up like vectors.